What happens when everything else that I've taught before fails? What happens if you are not able to use a change of variable to get the integral of a function? One way to solve it is probably achieved by doing the process that I'm going to talk about this lesson. This is called the integration by parts and is used when all the methods before fail. Good news, you can just go to the formula, this one over here, that you can also find on MF19. Here you have it, and apply it. But I don't like, as you probably already noticed, I don't like just to give a formula and take it for face value. I want to explain where the formula comes from. You don't need this part, so you may skip this part, but I invite you to look at it for you to have a more holistic understanding of how math works, and this will help you to anchor the formula and how it operates, how to use it on previous knowledge. Okay, I'm going to use two examples. So let's say that you want to integrate this function. You look at it and you cannot do the change of variable, right? If you differentiate this, actually this one you could. Let me just check very quickly. I promise I won't take much time. We actually differentiated that, didn't we? Oh, wait, trigonometric functions. No, apparently I didn't. No. Here you have to apply the integration by parts. Actually fits into one of the categories in which integration by parts is used. I just remembered. Okay, so where do we start? You don't know how to integrate this, so you start with thinking of another function that eventually, by differentiating it, will lead into this. That function is y equals x cosine of x. If you differentiate that function, what do you end up with? You do the product rule. So it's this. So the derivative of this times that. So that's just 1 times cosine of x. Plus the first one times the derivative of the second, which is x times minus sine of x. So this ends up being this. Now let's integrate both sides. I integrate this, and this is just y, right? I integrate this whole thing. I can divide it into 2, so the integral of cosine of x is sine of x. The integral of minus x sine of x, I can put the minus outside, is the thing that we wanted to begin with. See the purpose of all this? So what is y? Y, in the first place, was x cosine of x, right? So we can write this as x cosine of x minus sine of x, but that minus is going to flip the position, so it's just sine of x minus x cosine of x. So we never integrated anything directly, but we use another method to find the expression that we wanted. All right? What is the problem here? Where you should start with, okay? But I'm going to use this to get to the next, to the formula that I just mentioned at the beginning, and apply the formula and see how using the formula will yield the same result. I just want to go over another example. Let's say that you have this, another typical example that uses integration by parts. The most famous are these: a small simple polynomial multiplied by a simple trigonometric expression, or a simple polynomial multiplied by a simple exponential expression. Okay, these are typical situations in which you use integration by parts. So again, the starting point, that's the hard part for you, because there's no procedure besides just thinking a little about it on where to start, but I'll tell you that. So in this case, your starting point is exactly the same expression. After all, we are talking about the exponential function. If you differentiate e to the power of x, you have e to the power of x. If you integrate e to the power of x, you have e to the power of x, right? So That's not a mystery there. Okay, so we start here. Differentiate both sides and use the product rule. So differentiate that times that, and then this times that differentiated. All right? Now integrate both sides. This is just going to be y, and y is what? It's x e to the power of 2x. Integrate this. Integrating this part alone, we'll get e to the power of 2x divided by 2. Integrating this part will yield what you wanted. You just put the 2 outside of the integral sign, and this is the thing that you wanted. So now let's just reorganize that to get what we want. So this goes over here, divide the whole thing by 2. So the integral of x e to the power of 2x dx, the thing that we wanted to begin with, is going to be equal to that. Okay, so in general terms, this is coming from where, or what are we doing? We are dividing the thing that we want to integrate into two smaller functions, f of x and g of x. And the way that you have to think is thinking of one of them as being a function as is, and the other one as being the outcome of the differentiation of another function. In other words, one of them is u, as is, and the other one is just dv by dx, is the outcome of the differentiation of another function. And now, where are we getting this from? We are getting this from the product rule. The product rule applied to the original functions, to the u, and not this one, but the v, okay? So we are differentiating the function as a product of the two primitives, the u that you have here and the primitive of that. And this is just the product rule expressed as is. You already know this. Have this in MF19 as well. All right. And then what do we do? As we saw before, we integrate both sides. This will become just uv. This will become the integral of dv dx. And this will become the integral of, I put the v first, v du by dx. And then the thing that we wanted is what? Is this. No, sorry, is this one. Okay? So we bring this to the other side. So the thing that we want, when we isolate this, is that the integral of u dv by dx, the thing that we wanted in the first place, equals u times v minus the integral of v times du by dx. What does this all mean? This part you need to understand. This part is about knowing how to use this formula. Whenever you have situations like these two, I'm going to mention again, a simple polynomial times a simple trigonometric expression, or a simple polynomial times a simple exponential expression, is not limited to these two, but these two are the most famous. You do one thing. I'm going to use the first example to illustrate this. You look at the two options, and you pick one to be the function as is, so your u, in this case, is x, and you pick the other function to be the derivative, so in this case, dv by dx is going to be the sine of x. Then you do what? For this one, differentiate it. You do du by dx, which in this case is just 1. For the other one, integrate it mentally. So if this is the derivative, what is the primitive? Is minus cosine of x, that's your v. And now you have here everything to plug in the formula. So the thing that you wanted, which is this in this case, is what? Is u is x, times v is minus cosine of x, so you have minus x cosine of x, minus the integral of what? Of v, what is v? Is minus cosine of x, times du by dx, in this case is just 1. Where is it? Where am I? Times 1. Okay, don't need to write it, obviously. Times dx. And now you know how to integrate this. So what you want is minus x cosine of x. If you just integrate minus cosine of x, you have minus sine of x. That minus with that minus becomes a plus. So sine of x plus c. Here just reorganizing in a different way. Sine of x minus x cosine of x plus c, which is the thing that we got in the first place. Only that in this case you have the arbitrary constant c. All right? So, in a nutshell, every time you use this method, every time you use integration by parts, you will need to look at the function that you are integrating, break it down into two, pick one to be the function as is and the other part to be the derivative, so that you differentiate the one that is as is and you find the primitive of the other one, and then apply the rule. Now you may ask, how will I know which one will be the u, which one will be the dv, dx? In a nutshell, is going to be just practice, okay? The worst case scenario, you just do the other way around and you reach a place where you cannot integrate, in which case you go back and you swap the position of the functions, and that should solve the problem, okay? But then again, break the bigger function into two, choose one to be a function u, which is the function as is, pick the other chunk to be the dv by dx, okay? Then do du by dx for the first function, do the integral of the dv by dx to get the primitive. In other words, you are getting the du by dx and the v, and now you have everything that you need for this formula. You have the u, you have the v, you have the du by dx. Apply the formula, and that's it. If you are calculating areas, for example, or in any other situation in which you need to put the limits of integration, this is just the same, okay? Apply the same thing, but then work with the limits of integration on this part and on this part after you find that integral. In these cases, as you already know, when you use limits of integration, you don't need to worry about the arbitrary constant because it cancels out after you apply the b and the a in the final part of the calculation.